Alright, so in this video I'm going to be covering half-angle tangent substitution, which I like to call T-sub. And basically what this is a special version of U-sub that's specific to when you set U, or in this case T, equal to tangent of x over 2. And essentially all you're doing is just a regular U-sub, except you can kind of just remember these different rules and make your substitutions using these rules. So if you see a sine of x, you'll substitute in 2t plus 1 plus t squared. For all of your dx's, you'll always substitute in 2 dt over 1 plus t squared. And for cosine of x, you'll always substitute this in here. And I'll show you how to prove all of these rules at the end of the video. But first I'm going to show you why it's useful, and I'm going to give you guys two examples of when you might want to use T-sub. Alright, so one example of a time that you might want to use this type of substitution is for the integral of tangent x over 2 dx. So we can pretty easily rewrite this as the integral of t, replacing tangent of x over 2, and to replace dx, we can replace it with 2 dt over 1 plus t squared. And that comes straight from these two substitutions right here. So now we can rewrite this as one fraction. So that's 2t dt over 1 plus t squared. And now this is a much easier u substitution than working with something else. So we can set u equal to 1 plus t squared and du equal to 2t dt, which is just our numerator. So this is equal to the integral of du over u, or ln absolute value of u, which in this case is 1 plus t squared, plus c. And all we have to do now is substitute back in for t. So that's equal to ln absolute value of 1 plus, and we know that t is tangent of x over 2, but that's t squared, plus c. And you could circle that as your answer, or if you wanted to simplify even further, you could use trig identities and say that this is ln absolute value of secant squared of x over 2 plus c. And if you wanted to simplify even further, you could bring that squared out in front using log properties and say that your final answer is 2 ln absolute value of secant of x over 2 plus c. And so that's one way to use this sort of t substitution to help you solve an integral. Alright, so now we're going to look at a much harder example. So now we're going to do the integral of dx over sine x plus cosine x. And so you might start by trying to find some way to use a u substitution or something like that. But when you get stuck, what you're going to want to do is substitute tangent of x over 2 using these rules right here. So we can start off by substituting in dx. And dx, as we know, is just 2 dt over 1 plus t squared. So we can just write that down. And then this whole thing is going to be over. We're going to need to make our integral here larger. Sine, which is 2t over 1 plus t squared, plus, and then cosine is 1 minus t squared over 1 plus t squared. And we have our dt up here. So now we can go ahead and cancel all of these 1 plus t squareds from each piece, and we're left with 2 dt over 2t plus 1 minus t squared. And we could rewrite that as negative 2. We're pulling out negative and the 2, and we have dt over t squared minus 2t minus 1. And I'm actually going to stop here, but you could integrate this using partial fraction decomposition. Hopefully your teacher will never actually have you integrate this after this point. Hopefully they'll just have like a multiple choice answer that looks like this. But from this point, you would do partial fraction decomposition, and you have a lot of hard numbers, and at the very end, you would substitute in tangent of x over 2 for your t's. Alright, so now I'm going to show you all how to derive these equations. So I'm going to start with dx. I know that we're setting t equal to tangent of x over 2. So to find dt, we can simply take the derivative of this with respect to x. So that means that dt is equal to the derivative of tangent is secant squared. So secant squared x, which in this case is x over 2. And we have to do a chain rule on that x over 2, so we have a coefficient of 1/2. Now we can use trig identities to say that secant squared x over 2 is equal to 1 plus tangent squared x over 2. So this is equal to 1 plus tangent squared x over 2 all over 2. And since tangent of x over 2 is t, we can rewrite this as 1 plus t squared over 2 dx is equal to dt. So now we're going to solve this in terms of dx. So that means that dx we'll multiply 2 to the other side, 2 dt, and then we're going to divide by 1 plus t squared. And that is how you come up with dx. Okay, so now I'm going to prove the sine x substitution. So we're going to start by knowing the trig identity that sine of 2x equals 2 sine x cosine x. So we're going to keeping that in mind, we can say that sine of x is equal to 2 sine of x over 2 cosine of x over 2. Now, we're going to put this in terms of tangent. So in order to do that, we're going to divide this by cosine of x over 2. And we're going to multiply the numerator by cosine of x over 2. And this right here is essentially the same as multiplying by 1, because it's cosine of x over 2 divided by cosine of x over 2. But it'll help us make our math a little bit easier. So let's go ahead and rewrite this as sine of x equals 2, sine over cosine is tangent of x over 2, and cosine of x over 2 times itself is cosine squared of x over 2. Now we're going to go ahead and rewrite cosine squared of x over 2 in terms of secants. So this is times 1 over secant squared of x over 2. And we know that secant squared of x over 2 is equal to 1 plus tangent squared of x over 2. So this is 2 tangent x over 2 times 1 over 1 plus tangent squared of x over 2. And that's another trig identity. So now we can simplify this to be 2 tangent of x over 2 is just t over 1 plus t squared. And that is how you prove the sine substitution. Lastly, I'm going to prove that cosine of x is 1 minus t squared over 1 plus t squared. So again, we're going to start by looking at this trig identity that cosine of 2x is equal to cosine squared x minus sine squared x. So now we can apply that to cosine of x. It would be equal to cosine squared x over 2 minus sine squared of x over 2. From here, what we're going to do is we're going to factor out a cosine. So we're going to divide each of these terms by cosine. So that becomes cosine squared of x over 2 times, if you divide the first term by cosine, you just get 1. If you divide the second term by cosine, you get tangent. So that's 1 minus tangent squared of x over 2. So now we know that cosine squared is the same as 1 over secant squared. And we know that 1 minus tangent squared of x over 2 is the same thing as 1 minus t squared. Now we can again use the trig identity that secant squared is 1 plus tangent squared. And lastly, we just substitute in t squared for that denominator. So it's 1 minus t squared in the numerator from here over 1 plus, and this is t squared. And so that is how you prove the cosine substitution.